Hello, and you are listening to Bill Murphy's Red Zone podcast. I interview leaders who inspire me in the areas of exponential technologies, business innovation, entrepreneurship, thought leadership, enterprise IT security, neuroscience, philosophy, personal development, and more. Welcome to the show. Welcome back to the show, everybody. This is Bill Murphy, your host of the Red Zone podcast. Today's episode is called Why is the Google Cloud Platform Good for Your Business? And I asked Mark Mandel and Francesc Campoy Flores, who run the Google Cloud Platform podcast, to come on and talk to me about the Google Cloud Platform. This was a team that was recommended actually by a heavyweight that I just interviewed on the Google team, a high-level individual that talked about the security of the Google Cloud. And so I wanted to shift gears a little bit and talk about some of the capabilities beyond security within the Google platform. And I think it's important as a digital leader for you to understand what's going on both in the Microsoft side of the fence with Azure and the Office 365 tools, but also understand what's going on in AWS and on Google, because I think Google is coming from the kind of B2C world, but the B2B world is an area that they have massively expanded in, and understanding the benefits and what questions to ask and what things to go research with your teams is important. So we cover what the open cloud is, what Google's philosophy is on open cloud, and sort of the interoperability between their cloud and others, which doesn't force you into a vendor lock-in situation. We talk about Kubernetes and container orchestration, which you're hearing that word a lot these days, and looking at the container engine and being able to do orchestration at scale. And we talk about what the concept of lift and shift is related to that. And we also explain about Google App Engine, and on also creating managed services. So they have offerings within the Google Cloud, which allow you to kind of have full control, make it, break it, it's yours. Or they have more managed service offerings, which they take more of the pieces away so you don't get in your own way. So they have different options. And same thing on the Microsoft side as well. So very similar in that regard, that you have full control to less control, depending on what things you want to take off your plate. We talk about Google Cloud Storage and the concept also of the open source product Spinnaker, with the automated launching for process flows and container building and workflows. How do you get better observability within your systems? And then also, which I thought was fascinating, was the Go programming language and differences between the Go programming language and like C++, for example, and like as an IT decision maker, why the Go programming language, it could be really helpful for innovation and testing quickly products as you develop new capabilities for your business. So this has an innovation feel to it as well that I know I took away. So tons of links to different product sets that we've provided on this, also to some episodes where you can link out to some of the episodes they suggest would be really good for you to learn more about the Google platform itself. So that tees up today's episode. I hope you really enjoy it. So with that, I want to introduce you to my conversation with Francesc Campoy Flores and Mark Mandel. Thank you. Well, Francesc and Mark, I want to welcome you to the show today.
Thank you.
Thank you very much.
Well, this is a real pleasure because I've never done the kind of a three-pronged podcast here, so it's kind of this is really fun. Have you guys ever done like three people on your own podcast?
Three guests? No, we've been four people at the same time, but two hosts, two guests.
Yeah. Oh, okay.
Yeah.
Well, I'd love to give my audience, this is a little bit of a different spin that I want to take for today. And I'd love for you guys to talk a little bit about your own podcast and kind of like, how did it get started and what do you all hope to accomplish from your own podcast? Can you give a little history about that for my guests for today?
Sure, I can get started and Mark will give more detail.
Sure.
So basically, I've been in developer relations at Google for, like 5 years or so. And for a while, I had been thinking about the idea that podcasts are very useful. Like I personally listen to podcasts, and they're a very nice way to learn, and they're very personal. You can really put your turning to things and express the things the way you really want, which is not the same way with writing. So I was thinking about making a podcast, but I always thought that it was a lot of effort. And then Mark joined Google, how long ago? 3 years now?
2.5, something like that. Yeah.
Yeah, 2.5. So he joined Google and I was his mentor. And once he was like, let's do a podcast. I was like, okay, let's do a podcast. So there you go. Now we're doing a podcast.
That's pretty accurate. Yep. Same thing here. I've been a podcast listener for a long time, realized there wasn't one for GCP or Google Cloud Platform. And yeah, sort of Francesca and I were sitting down and we were like, we should do a podcast. We're like, okay. So we didn't think it would be a lot of work, but we discovered that it was a bit of work.
Oh yeah. But after the fact, we realized.
So you clearly, I got directed to you from the Google folks, so you clearly caught their attention.
Yeah, so we've had really good sponsorship internally. So the audience reaction to the podcast has been great. We get even just people on the ground coming up to us and saying like, this is amazing, we love it. Both internal to Google and external to Google, which has been fantastic. And so the support from internal has been fantastic as well. So it's been a hugely positive experience, I must say, starting this up.
I think that we were really, like, we're in a very privileged position where we have access to people like product managers and engineers and people that really, really work in the project, in products for a very long time. And we're able to get them on the podcast and ask them all of the questions that people have. So it is kind of an easy way for us to just extract all of the information that we want. And apparently other people find it interesting too.
No, that's great. And I love talking to product managers. And I've had a couple on my show, and it's really interesting how deep people are in certain areas and how much wisdom they have. And one of the things that I wanted to kind of pretend like I was a CIO, and in many respects I am, and I really want to dispel, like I spend so much of my time, as I share with you, talking about AWS and Azure, but I really want to understand more deeply about the Google platform. And we've just had a guest on talking about the security aspects of the Google platform. But I'd love for you to talk about what you guys feel is one of the things that just the market, the buyers really don't understand about the Google platform that is important. And it could be related to containerization or Kubernetes or anything. But what do you think it is?
I have answers. Do you want me to jump in? I have thoughts. I think there's a lot of differentiating things. I think between the clouds, we all have various opinions on stuff. One of the things I particularly love about Google Cloud is the philosophy of the open cloud or the hybrid cloud. Within Google Cloud, we use this phrase a lot. Well, we definitely have sort of the proprietary type stuff where it's like you use this, there's, you get really quick to market with this technology because we manage it all for you, but you're sort of locked in. But I think we really talk a lot about the open cloud. So using open source things such as Kubernetes, such as containers, basically enabling it so that if you want to run on us plus somewhere else or run on like another cloud provider or maybe your own machines or move from your own machines over to the cloud, open source systems such as Kubernetes and container orchestration as a whole really enable you to do that. And we like to think that we're going to be the best place for you to run those workloads. But at the end of the day, you win because of the competition. As the consumer, you win because we're all vying for that arena and that kind of Kubernetes standard, which I think is really cool. And we basically are leaning on the idea that we think we're going to be able to give you the best experience to be able to keep you here inside Google Cloud, but we're also going to give you the ability to leave if you need to.
Yeah, I definitely agree with that. And following with the thought of trying to make it the best place to run open source technologies, we have things like TensorFlow or Kubernetes. And basically the whole idea is that you could run it by yourself if you want to. So there's no vendor lock-in at all. You can do whatever you want. What we're going to do is we're going to try to do it. So we're going to try to minimize all of the DevOps and all the operations that really they're not part of your business. Like you're doing something cool on top of those tools. Those tools should be there for you rather than you being there for the tools. So for instance, with Kubernetes, we have Google Container Engine. And with Container Engine is to start a new cluster is literally one form. You click a button and after a couple of minutes, you get a new cluster. And then from there, all of the operations are automated. So if a machine goes down, it just gets restarted. But also if there's new versions of Kubernetes and everything just gets updated without you having to care that much about it, which is really what people want.
Is it really designed for people developing their own systems? Or would you say that you could move your own workloads directly into the platform? Or is it more from a development point of view that you see people moving into the Google Cloud Platform right now?
Yeah, so we've seen both. As part of the podcast, the Google Cloud Platform podcast, we've interviewed many different people. And we've seen people doing, I think it's called, I always find it funny,
lift and shift.
Lift and shift.
Lift and shift.
Is it shift or lift and shift?
Lift
and shift.
It's one of those. And where basically they have their own software running on their own premises, and then they just decide to move it to Google or Google Compute Engine, where you get your instances and you decide exactly what machine you want, how much RAM, how many processors, if you want GPUs and stuff like that. And you really have a very fine-grained decision on this. But we've also seen people doing completely the opposite and just building directly on the platform like Greenfield and really using all of the completely managed services like App Engine. So App Engine basically, it allows you to give some code and just say, run this, scale as much as you need, and just make it work, right? So it's perfect for things like, I don't know, like Khan Academy or even like Angry Birds. The backend of Angry Birds was running in there because they have like really huge spikes.
What was the name of that tool?
It's App Engine, Google App Engine.
App Engine, okay, got it.
Yeah. So application engine, App Engine, yeah.
Oh, I got you, App Engine.
Yeah.
Okay.
Yeah, to go on from that, I think that's, it is interesting. We've had for a while, one of our biggest episodes was just our episode on virtual machines, right? So just like we have this thing called Google Compute Engine. If you need a particular instance, right, you want to spin up Ubuntu or Windows or CentOS or whatever. And while we generally spend a lot of time sort of on the podcast talking about that new shiny thing, like something like App Engine, something like Kubernetes, something like Spanner, like all those really cool special things, sometimes people just need like an instance with, some compute and they need to build stuff. And that's really cool. And I think that's great. But then we also have like the big managed services that enable you to not have to do a lot of the work, whether you're, something on App Engine where you just want to run a bunch of stateless, say, HTTP endpoints, or even something like Spanner where you want to have essentially a globally replicated data store where you can basically do SQL and relational operations. We often talk about sort of compute as the continuum, right? So how much do you want to control versus how much flexibility do you want, and how much do you want us to manage it for you, right? So like the infrastructure on like VMs at one end, which is like you do everything, but you have all the control and the flexibility you like, to something like App Engine, which is much more constrained, but we manage so much more for you. And then sort of containers and GKE, like Container Engine in the middle, and a few other options as well. But the same thing is also, Cloud Functions, if you want to get into the Lambda side of things. But then also on storage, we have everything from, Google Cloud Storage, where you want to store binary stuff, to if you want to run your own MySQL instances on VMs, you could totally do that as well. But we have like Managed MySQL, and then we have things like Data Store. Firestore came out recently on the Firebase brand, which is tightly coupled to ours. A couple of like managed NoSQL data stores, as well as things like Cloud Spanner and Managed Postgres and things like that. So there's lots of ways you can sort of chop and change how much control and how much you want to have managed. And you can make that as a business decision, essentially.
When the managed service piece comes up, when you're talking about that being more of the DevOps orchestration, is that where someone can leverage essentially more of a workflow-based way to manage? Is that when you guys, they would be outsourced, they're giving you more of that capability to help them orchestrate? Is that what you mean by managed service?
Yeah, so basically the whole idea is to go on with the example for storage. Like let's say that you want to run a MySQL database, right? You could just simply start a couple of VMs and just run MySQL there, right? Now, the problem is that you're going to have to manage a bunch of things. One of them is, well, if there's a new version on MySQL, you need to upgrade it. You need to make sure that everything is running all the time. If it goes down, how do you manage your replicas and all of these things? You need to also configure backups and all of these things, right? Like if you're a DBA, you know all of these things that you really need to do. Now, if you're not a DBA and you want to have just a MySQL instance running, you do not need to care about all of these things. So instead, you can use what we call Cloud SQL. And Cloud SQL is simply MySQL, and now also Postgres you can choose. But basically a MySQL or Postgres instance running in the cloud, fully managed by Google. And this is cool because basically this comes from Google doing it internally. At Google, there's a lot of teams that used to use MySQL. Now, I'd say not that much. But we used to have a lot of people using MySQL. We didn't want every single team to manage this by themselves. So we created a managed service where they could just say, hey, give me one instance, right? So we basically just made this available for everyone.
Which I think is really good because I think from a lot of the innovation conversations I've been having is that the ability to stand up and test and build something on the fly and fast, I think is what companies really need to have that capability. I think Doing it within their own four walls, though, can be problematic because it's using resources and you've got to fight to have the services allocated for you. So the ability to do it on demand seems very appealing.
Yeah, no, I agree 100%. It can be very difficult otherwise to do that whole test stage prod type thing in a cost-effective way when you're dealing with real machines, especially if you want to test out. I mean, we had a game, Phoenix One, Guardian Kingdoms. They literally just did a lift and shift across over to Google Cloud. And one of the big things they were talking about is now we can test real load on a system that looks exactly like our production system because it's all virtual. We can build it up, do their load testing, tear it back down, and it's a fraction of the cost of keeping this thing running in real time. And we can also then say, okay, well, what happens if we doubled everything in size? Can we still handle the load? Where do our bottlenecks sit? If we want to do like 10 times the load that we normally would have within this game, then suddenly you can start playing these sort of games with a much more flexible way than you would be able to otherwise.
And even from the point of view of a developer just writing something really small, like I've had this experience before where I'm writing, like I use a MacBook to develop, and I'm trying my things, and it works in my machine. I use Docker, and it still works. And then I really want to deploy it to like production. Creating a new instance is going to take like around 1 minute. And then I can SSH into it directly and just try my thing and make sure that it actually works, right? And there's where you realize that actually, well, what you like, your expectations were not actually accurate. So what you thought would work, it doesn't. Being able to do this so fast and without having to ask for permission to anyone to have a new instance really changes the way you develop. So it's really good.
So what is Kubernetes? Am I pronouncing it right? Kubernetes?
Kubernetes. Yeah.
Kubernetes. Like from just a layman's perspective, what is that and what is it compared to? And then how would you define it? And then what is it like or what is it dissimilar to?
I'm going to let you go, Mark.
Okay, that works. So the tagline reads something along the lines of Kubernetes is open source container orchestration at scale. What does that actually mean, though? The way I like to look at it is if you sort of take the buzzwords out of it, the general gist of it is you have a cluster of machines. So you probably have maybe 3, 5, 10, 5,000, but you have a huge number of machines. You need a piece of software to manage what processes start up on them, where they start up, whether they have disks attached to them, taking all their logs, aggregating it together, making sure things are healthy and available, and if they aren't, restarting your systems, deploying new versions of whatever software you have, and basically all the general stuff that you need to manage and run software across a large cluster of machines such that you can scale and deal with information coming in and going out, right? This is basically what Kubernetes does. There's a bunch of things that are underneath it in terms of like you want to talk about Docker and containers and standards and governance and stuff. But at a very core level, it really just gives you a massive amount of control over exactly what processes are happening across a large cluster of machines. That gives you a bunch of different ways to do that, from configuration files you can deploy that tell it exactly what you want to do. Like, I want 5 instances of this thing running somewhere in my cluster. And at the end of the day, I don't care where, but as long as it runs and I can access it, that's great. And Kubernetes will take care of that for you. All the way through to APIs that you can integrate directly into Kubernetes so that you can have very fine-grained control over exactly what's happening as well. And it's all open source, which is super cool.
Okay, a couple questions on that. So if I just had this happen this week, I'm in talking to a CIO, and he says, I'm just losing track. I said, all my developers are all in my production code. I have no roles-based access control to parts of the code. So he doesn't have authentication. He doesn't have authorization, none of that. So where does security start for you guys? It's probably a problem that many companies have.
Yeah. So first of all, he has to fix that. That is indeed a problem.
This is not a problem that I'm sure that Google has or big companies, but this is like small to medium businesses, like 100 employees to 5,000, which is most of the US businesses. This is real stuff. This is hard stuff.
Yeah. So the cool thing about Google Cloud Platform is this is something that is relatively new, and it's something that we added because basically our customers were asking for it, right? Was the fact that you really want to have, for every single way of authenticating, you want to allow those people or processes to do something specific and no more than that, right? So there's what we call IAM, Identity and Access Management, I think it stands for.
Sure.
And basically that's going to allow you to say, well, like this person they're able to access this specific bucket on Google Cloud Storage, or they're able to manage this instance on Google Compute Engine, right? So you're going to be able to give very specific rules to what people can do. Now, the thing is that you can use exactly the same idea to apply it to processes. So you could say, it's like I have this process. This process is going to be running on this instance, and this instance on Compute Engine will only have access to only read from cloud storage, right? So with this, you're going to start creating really, you're going to try to minimize the surface area of how someone getting access to one of the pieces of your system will be able to impact the rest. And then on top of that, the same idea is also available on Kubernetes, if that's the question. Kubernetes also has rule-based access control. And Mark knows way more than me about that.
I know a bit more. I've not played with it in depth, but yes, Kubernetes definitely has RBAC authorization. So again, it's open source, built in. If you're using Google Cloud Platform, there are links between RBAC and IAM that you're able to take advantage of, so that you do have that fine-grained control over who can deploy and when they can deploy and all that sort of stuff. To tie it into more open source, which I think is totally valid as well, we also have deep integrations and a continual involvement in another open source project called Spinnaker. And so Spinnaker, it works in the continuous delivery side of things. So in the way that you were talking about, where you sort of have a CIO who has those sort of problems, it also sounds like what they may possibly also need is a system such that when a developer builds a feature, there needs to be some kind of automated pipeline that does tests and make sure everything's okay. But once everything's okay, automates the deployment part of things.
Yes, wouldn't that be nice?
Wouldn't that be nice? So Spinnaker is another open source project that you can use in conjunction with Kubernetes and Container Engine and Google Cloud, and actually a variety of products across Google Cloud, wherein it gives you lots of pre-built stuff for doing automated deployments. And so it's not this one particular developer sitting in a cubicle hoping to write this config file just right to make sure things are okay. You have an automated deploy that you're able to set up and then say, maybe you do it every time, maybe you do it every, on a certain time of day, maybe there's a push button on some smoke tests, but you have an automated system so that potential for things going wrong really gets reduced.
So I'm probably going to use the wrong word, or maybe I'm not even going to remember the word at all, but it was the controlled, kind of the more controlled piece of the platform, and then there's the kind of more open, free part of the platform where you can do more of what you want. My question is more on the more controlled part. That's more, we kind of, I guess, would have more discipline around around building and deploying. First of all, what's the name of the product?
Oh, so I was talking about Spinnaker. Spinnaker is it's an open source product. If you want to run it on us, I'm just actually double checking. We have an automated launcher for common things, and Spinnaker's in there, so you have a one-click push to deploy. So you can just go in and fire that up, so you don't have to necessarily set it up. But it works with the wider Google Cloud Platform as well as thing. If you're looking for something to tie into that's maybe a little bit more managed, or maybe even just a little simpler, we also have a product called Container Builder, which is a bit of a misnomer in how it's named. It sounds like it's a thing that builds containers. What it actually is a thing that uses containers to build stuff. But what it essentially is a way to set up a set of basically steps within a workflow using some simple configuration files, so that you can say things like, when this code goes into a source, say GitHub or one of our source repositories using Git or any version control system pretty much, or a variety of other hooks really, then I want these steps to run. And those steps might be run some tests. They may actually be, I'm just going to do a simple deploy somewhere, all that sort of stuff. So you have a lot of several tools at your hands to be able to control what happens when you push code into your version control.
Can you build the security layer in, at least on the access control piece, in as you go as well? Does that sort of work people through that process so they're not trying to reverse engineer it on the back end?
I mean, something you could do to avoid the problem where you were mentioning that basically everyone has access to everything in production is to basically say no one has access to production. Everything needs to be done through either Container Builder or Spinnaker or any other way of deploying that you decide to use. And that's basically what we do at Google, really, where what you're going to do is everything needs to go through the Git repository, right? So you cannot just go somewhere and say, I'm going to change this job. No, you don't do that. Instead, you go and you change the code or you change some configuration. That gets reviewed by other people. And then once it gets merged, then it's going to be deployed to QA. And then there's going to be some tests that then will actually be hitting production, right?
No, and
this is something that it requires organization and a little bit of what's the word they're looking for? basically you need to be able to tell your developers that this friction is actually useful in the long run. At the beginning, it's gonna, yeah. At the beginning, it's gonna be adding friction, but later on, it will make it so your deployments will way faster. Like once you automate your deployments, everything is so much better.
We have the same thing on the firewall side. Sometimes we get in. I mean, this not so much in these days, but sometimes these firewalls get so much Swiss cheese that there's just so many holes punched in them, and you just got to flatten them and basically say nobody gets access anywhere. You got to build the rules from scratch instead of granting everybody access to through the firewall. So it's an interesting parallel.
Yeah, but the nice thing is, because we have IAM and RBAC and that stuff, you can still give people access in terms of being able to visually see what's going on. So if they need to debug something or see what's happening, those tools still exist, and you're not getting in the way of developers that way. But not to the point where it's sort of like, oh, I can just change this thing here. It's more, I can still see what's going on. So you don't want to be like making it so that your developers aren't able to like triage issues if like something goes wrong, because software fails. That happens.
In my opinion, if your developers have SSH access to machines in production and they actually need it, there's a problem that you should fix somewhere.
That's fair.
In general, you should have better ways. Yeah, you should have better ways of debugging things. You need a better system to monitor. Like you need better observability of your system, basically.
Yeah, that's a great point. There's a root cause issue going on, and they're trying to have a sledgehammer killing the mosquito, and they don't need it. That's a great parallel. So while we're on the programming languages, I noticed both of you, or maybe it was Francesca, had some really interesting material online about the Go programming language, correct?
Yep.
And what is that? I want to ask a question that hopefully doesn't make me look too idiotic, but if I'm a decision maker and I'm trying to make good decisions I want to rapidly iterate, I want to develop new tools and products and apps for my business, and I've got this whole legacy going concern business, so I can't disrupt the core of the business, but I want to innovate at the edge. Could I train up some young kids on the Go programming language, maybe coming out of school, or like what is it, and why do you guys like it so much?
Okay, so I have two different pitch elevators for you. The first one is for developers, right? Like for people that actually program. I'd say that Go is kind of like the soft spot between something as expressive and fun to write as Python, where you just write your thing and basically everything works. Plus the performance and security of, I was going to say C++, but I'm going to go with Java because I said security. So basically, you're going to get to a point where you write code that is compiled, like in C++, you get something really fast and very efficient. Plus, you get concurrency, which is really important nowadays because like you can create virtual machines with 64 cores. If you're not using them, you're wasting money. But at the same time, when you write the code, it is actually very simple. The main goal of the language is simplicity. So the second part of the pitch is if you're a decision maker, learning Go is super easy, right? The language itself I'd say that maybe it will take like 1 day to learn the whole specification and everything that there is in the whole language, which is really good. After a week, you're able to write code decently. And people say that like after a month to 3 months, you're like a good developer. I'd say it depends on how much code you're writing and stuff like that. But it is true that you learn really fast. And the main point is that through enforcing this simplicity, what you're doing is you're forcing developers to really go for the most simple solution that works, making your code boring, I would say. Like Go code I've never seen Go code that I was like, whoa, that's so smart. That's awesome, right? While in other languages, I've seen that pretty often. So it really goes into a very pragmatic effort on this is a language to write systems that require things like concurrency, good network stack, and also collaboration across many different people, right? You're going to keep it simple, and that's pretty much it. And I think that's why systems like Kubernetes that we were talking about, it's written in Go. It is partly because Kubernetes is going to be running with Docker. Docker was also written in Go, but also because you really want something that is able to use all of the cores in a machine, that is able to use them efficiently, so something compiled always works. but also you wanted to use all of the concurrency and all the networking stack, which is, I'd say it's really, really good. And on top of that, it's open source. For an open source project, you really want people to be able to onboard the project as easily as possible. If you have languages that are, for instance, very good for networking, like for instance, I'm thinking about Erlang. Erlang is a great language for networking. It was designed for that. But learning the language itself is actually not easy. So that's why I think Go is having this really popular phase of basically every single new project. I have this joke that's like, if it has cloud in the name, probably it's running Go. And it's kind of true nowadays.
So basically, the concurrency you're referring to is basically that Go is really efficient to be used across the multiple processors. So it really makes great use of hardware. Is that one of your points?
Yeah, you can create. So we don't use threads, but I mean there are threads, but they're hidden behind it. You don't see it. You don't see them. We use Go routines, which are like coroutines or like green threads or whatever you want to call them, and you can create easily millions of them, and everything works very well. So when you're able to create like millions of coroutines, they're distributed across all of your processors in a very efficient way. You're really using your processors as much as you can, right? So that is exactly what you want. You want to be able to, if you have a powerful machine, you should be using it.
So I'll plug episode number 25 of the Google Cloud Platform podcast, which we do Go on the Cloud with two of the Go team members, Andrew Durand and Chris Broadfoot. It's hilarious episode. But also we talk a lot about the Go programming language, how you can use Go on Google Cloud Platform, but also the wider implications of Go on the cloud, just like Francesca is talking about.
And also my first time interviewing 3 Australians at the same time.
Yeah.
And you're dialing into this from Australia, is that correct? Or are you in...
No, I live in San Francisco now. I've been here for the last few years.
Fantastic. Well, do you see the future of software programming? If things are getting super simple, then where do you see the direction of programming talent going for the future? Do you see the development of lessening the need for high-end programming talent from a quantitative perspective, or are you seeing more of a layering in of more creative talent if things are simpler and kind of obfuscated from the code point of view? Does that free them up to do other interesting things? Like, where do you guys stand on that?
I have opinions on this.
Go.
So I think that there's 3 different things that I see that I'm pretty excited about. One of them is like languages that are specifically designed for simplicity, right? Like Go is one of them. Ruby was one of them too, even though I'd say that like Ruby became more into fun more than simplicity. But the main idea being really enabling developers to create cool stuff, right? And this creates a new kind of developer where they don't really care about how garbage collection works and stuff like that. They don't really want like high performance. What they want is to be able to write their code and see it work and being able to deploy it somewhere and just everything works. And that's nice, right? And I think that is really important because it enables the open source community to grow, which is what I want after all. On the other side, though, I also see languages that are being created with specific domains in mind. So for instance, I see Rust, or I see, there's another cool language called Lasp, so Rust was created specifically for when you really care about memory, right? It is like a safer version of C++, I'd say. And it's really, really interesting. It is not as easy to learn, but it is really powerful for specific things. Like, for instance, I see it used in rendering for Mozilla. That's why it was created in the first place. But also I've seen it used in things like cryptography and stuff like that, where you really, really care about fine-tuning that performance. And then other things like Lasp, where the whole idea is to build a new language that will allow you to write distributed systems correctly. And I think that is really interesting and where the future is going, where we're going to have languages that allow you to express things at even a higher level. Right now, when you want to do something that is distributed, you really need to think about all of the different protocols of how the different pieces communicate across them. And I think that will change at some point. And instead, we will just describe what the system should be doing from a slightly higher point of view and just let the language decide how everything works specifically. But that's what I think.
I love that. Yeah, I think that's great. And I love your answer for that. Mark, I don't want to jump in if you had something to say there.
No, I think actually Francis covered that quite well.
Fantastic. Good. Well, what am I not asking that would be super interesting for my audience to hear about Google, about what you guys are developing? Is it true that you're allowed to give 10% of your time back to developing new things as a Google employee?
I don't think it's 10. I think it's 20. But
Yeah.
yeah.
20. Okay.
Yeah, we have this rule of the 20% where you're supposed to do whatever we want. But I'd say that as developer advocates, we do whatever we want 100% of the time. So it is pretty hard. Like, it is true that we personally spend a lot of time learning stuff and writing things that do not necessarily have an impact on what I do. Like, I work very closely with the Go team, but lately I've been learning TensorFlow because I feel like it, right? And it is useful and it is very interesting, and it also helps conversations that I might have later on. But for engineering, it is true that there's a 20% time, and it is pretty cool because we actually get, even in our team, we get sometimes people from outside of developer advocacy helping us as 20%, right? So people from software reliability engineering or software engineering that want to help us tell better stories. And it is super useful. It creates this environment where collaboration is actually required almost rather than frowned upon.
I would definitely agree with that. And even cross purposes. I mean, I have other teammates in DevRel themselves who I've been doing a lot of work in the gaming space, but I've had some people who sometimes focus on other communities, maybe language specific like Python or something like that. But they've come and said, I want to do 20% in the gaming space. So if there's a project or something that I can work on, please let me know. I'll go looking as well. So there's a lot of cross collaboration there, which is quite nice.
So you guys are involved in a lot of different efforts. It kind of seems like you span from gaming platform to talking about the things we were just referring to. So it must be a very, very interesting place to work.
Oh yeah,
it's highly distracting.
Well, is there anything as we get wrapped up, anything that I missed asking you guys that you're just super wanting me to make sure I ask, or anything that you think would add value to my audience to wrap things up?
I will mention one thing. So we have episode 100 of the Google Cloud Platform podcast coming up. We have the distinct pleasure of interviewing Vint Cerf, who is one of the founders of literally the internet, if you're not familiar with his name.
That's an amazing guest to have on.
Also a very snappy dresser.
Yes.
But I mean, that's not that important. We've got a hashtag running on Twitter called Ask Vint. So if you have particular questions that you want us to ask him, please make sure to reach out to @GCP Podcast on Twitter with the hashtag AskVint with your questions. We're definitely collating stuff from the audience because I think it's going to be a hugely interesting but also entertaining conversation.
Oh wow, yeah. That's amazing. I can't wait to listen to that myself. Francesc, anything for yourself or?
Not really. Just to add that most of the things that we've mentioned today, there's full episodes on the Google Cloud Platform podcast about them. So like if you're interested about like Kubernetes, it's not one episode. It's basically half of the podcast really. But we also have like Spinnaker and all of the TensorFlow things that we've been mentioning. Just go check it out. And hopefully people will send us as many questions as they have if there's anything that we forgot to mention, because right now I cannot think of anything.
Would you prefer people, because I'm going to link up all of the show notes and all the things we mentioned for you guys in particular, if there's people that want to reach out to you, would you prefer Twitter as a way for them to connect?
Should we do the
oh my god
how to get in touch with us?
do you want to and Bill, if you're happy for us to go through the spiel?
Yeah, go ahead.
All right, let's do it.
It's like 1 minute, but we're highly trained at this. Okay, so we have a website
at gcppodcast.com.
We have an email,
hello@gcppodcast.com.
We're on Twitter
at gcppodcast,
on Reddit
/r/gcppodcast,
Google Plus
GCP Podcast,
and finally on Slack.
You'll find us in the Hash Podcast channel at bit.ly/GCP-Slack.
Oh, that's fantastic.
Can you see we've trained at this? Like
you're well trained on that. That's great. Well, guys, I've really enjoyed this conversation, and this has been enlightening, and I've had a lot of fun. So until next time, thanks again.
Thank you.
Thank you so much for having us.
We'll see you soon. Thank you.
So there you have it. This wraps another episode of Bill Murphy's Red Zone podcast. To get all the relevant show notes, please go to our blog at www.redzonetech.net/podcast. Additionally, make sure you go to iTunes and leave your comments in iTunes about the show. This helps our show rankings enormously, and it helps support the show. Until next time, I appreciate you very much for listening. Thank you.